everyone. Now we can start a new topic, that is time versus settlement curve. So let me write the name of the topic, that is time versus settlement curve. Now in this time versus settlement curve, two types of curves we can discuss. So let me write the case number 1. So here we have the case number 1, that is under the same, I can write case number 1, time versus settlement curve, time versus settlement curve in different soils, under the same impact, or under the same increment of load, increment of pressure or load. Okay, so what happens? We have this case number 1. Suppose we have two soils. First I will be taking clay and the second will be sand. So if I draw the time versus settlement curve, this is your time versus settlement curve. On the horizontal axis I can take the time, and here on the vertical axis I can take the settlement. So if I talk about first if I talk about clay, then this is the time versus settlement curve for the clay. If I talk about the time versus settlement curve for sand, so for the sand this is the time versus settlement curve. Let me draw again properly. This blue color curve is the for clay. If you want, I can write this is for clay, and for sand I can prepare this is for sand. One thing people should notice, for the clay soil lot of time is required and the settlement is also very large. Final settlement is also very large and time required is more. In what condition? In primary consolidation actually. This time versus settlement curve, for which process we are discussing? For primary consolidation we are discussing. So in the bracket, if you want me to write, I can write time versus settlement curve in primary consolidation. Okay, so in primary consolidation, if I talk about clay soil, it takes lot of time to complete the primary consolidation, but the same primary consolidation has been completed within the finite time in sandy soil. What is the reason? Why clay is taking a lot of time to dissipate or to remove the excess water pressure, whereas in the case of sand it can be done within a given finite time. So let me explain. The clay is a plastic soil and sand is a non-plastic soil. For the clay soil we have very less permeability, and for sand we have higher permeability. Therefore the water drainage is very good in the case of sand, and water drainage means the drainage system in the clay is very poor. That's why the permeability, if the permeability is very less, then it takes a lot of time. Suppose I take one bag of gravel, one bag of clay, here I give 1 glass of water, here I give 1 glass of water. In what case, in which condition, in case of gravel or clay, I will receive the water first? Definitely in the case of gravel I get the water first, Why? Because the permeability is very high, water can be easily drained out. Same condition here occurs also. The permeability of clay is very less, it takes a lot of time to drain out, therefore the time versus settlement curve is going up to this much time, whereas this primary consolidation can be completed within a finite time in this process of time versus settlement curve for sandy soil. Okay, so in the case of clay soil, infinite time is required. In the last lectures actually we have discussed about primary consolidation, so you people know I have mentioned t greater than or equal to infinite. So for clay soil, infinite time is required to complete the primary consolidation. This is the one thing, infinite time is required for completion of primary consolidation. This is the first thing. And the second thing, the settlement is also very large as compared to sandy soil. Final settlement. That means we people are interested in estimating the settlement value, of course in the case of clay, because it is dangerous for me, it shows large settlement. That's why now I will be discussing each and every point about the consolidation only in the case of clay soil, not in the case of sand soil, not in the case of gravel soil, or not in any other soil. We are interested only and only about clay soil. That's why in the previous lecture, if you see, you will find I have mentioned NCC, normal consolidated clay, OCC, over consolidated clay. I have not mentioned over consolidated sandy soil, no. I have not mentioned normal consolidated sandy soil, no. We are interested only in the case of clay soil. Why? Because the settlement is large and it takes a lot of time. That's why the consolidation study is performed only and only for clay soil. Clear? So whenever question is asked, whenever we solve some problems or any experiment we do, that shall be discussed only for clay soils. Clear? Now, so this explanation, if you want, I can write here. Clay soil clay soil is non-plastic soil having less permeability, therefore it takes infinite time to complete the primary consolidation process. Okay, primary consolidation process. Therefore we are going to discuss all possible theories, all possible studies and or theories about consolidation for clay soils only. Okay, so in the case of clay, actually we will be talking about everything about the consolidation. Now one thing people should notice, in the case of sand, settlement is less, as well as final settlement I am talking about, not intermediate settlement. Final settlement is less and it takes very less time to complete the primary consolidation or to complete the consolidation. So what happens, I told you in my previous lectures, compaction is done before the construction of building. compaction is done before the construction of building, because it is an instantaneous process. You apply the load, air can be removed. But if I talk about consolidation, so it is a time dependent process. Clear? If it is a time dependent process, I cannot wait for next 5 years or 10 years. So consolidation we want to occur naturally under the shell fate of the building. We do not do anything for the completion of primary consolidation. It occurs naturally after the construction. So compaction before the construction, consolidation after the construction. But sir, is there any possibility of completing some part of consolidation before the construction? Can we perform the consolidation before the construction? Yes, there is a process. There are some techniques known as sand drains. We have some sand drains. Sand drains means, suppose we have one ground something like this. Here in the ground we penetrate some perforated pipes. These are your perforated pipes. Perforated pipes. Perforated pipes means on the periphery of these pipes number of holes are present. This is the hollow pipe, and on the periphery number of holes are present on this pipe. And here also we provided the top one horizontal pipe, and what will happen, these pipes are penetrated in the soil, in the clay soil, for which consolidation we have to perform in the given finite time. So suppose we have one ground which is having clay soil, in that we can insert these perforated pipes, and in these perforated pipes sand is filled, and you know sand is having high permeability and it takes very less time to complete the primary consolidation. So what happens, from this and we apply the force, so what happens, water comes in these pipes, where sand is present, and when the water comes in this pipe, of course under the pressure water is entering in these perforated pipes. There is some mechanism of taking the water in this horizontal pipe. This water will rise here and it can be collected, it can be removed. So in this pattern, whatever the amount of water is present in the clay soil, if I go through the natural process, it takes infinite time to remove the excess pore pressure or excess water. But if I go through these sand drains, I am inserting some perforated pipes which are filled with sands, and through these perforated pipes water is entering in the pipes and then the water can be removed out. This process can be done on the basis of the property of this sand, because the sand is having higher permeability, water immediately comes in the sand and it can be easily drained out, so, and it is taking less time also. That's why at some places which are highly waterlogged areas. Waterlogged areas means they are water table at the ground surface, I can say, or a lot of amount of water is present, the soil is very loose. So in such cases sand drains can be used to remove the water, to pump out the water. Okay, so these sand drains are actually the applications, or I can say the explanation of this concept, time versus settlement curve. Within the finite time we have done this. So before the construction also you can see consolidation is happening before the construction in the finite time. Fine. So sand drains is one system on one process. If you want, I can write here one note I can write, that is, sand drains can be used since sand have higher permeability and they are non-plastic 1 minute. Here by mistake I have written plastic, non-plastic. It is plastic actually, okay. Clay is a plastic soil. Please note down, if you have written non-plastic, cut the non word, okay. Clay is a plastic, by mistake I have written. Since sands have higher permeability and they are non-plastic, therefore they are used where? In the sand drains, to perform the consolidation. See, I am not telling the complete water can be removed through the sand drains. No, some part can be removed. Some degree of consolidation can be performed. Okay, up to some level you can perform the consolidation, but not 100%. So perform the consolidation process up to the satisfactory level, or up to the desired level, or satisfactory level. Okay, so these are the applications of sand drains. Fine. Now this was the time versus settlement curve that we have discussed here. This is the case number 1, where we were talking about the different types of soil but having the same load. So suppose on the clay soil I have prepared 5-story building, then on the sandy soil also I have prepared the 5-story buildings. Okay, means both the soils are subjected to the same type of loading. That's why I have written time versus settlement curve in different soils. Soil 1, soil 2, clay soil, sandy soil, under the same increment of pressure or load, under the same load we are having this time versus settlement curve. Now we can talk about the case number 2. What is the case number 2? So here I can write the case number 2. Case number 2 that we have, time versus settlement curve, in what sense? Time versus settlement curve in clay soil, under the same increment of pressure, okay, same increment of pressures. Now what is the meaning? The meaning is, now I am talking about only clay because we have discussed why we are interested in the clay. So let me talk about only clay soil. If I talk about clay soil, time versus settlement curve we understand. This is the time and here we take the settlement. Now you people will think, sir, why you are drawing the system like this? Why not? You people will think, why not like this? Why you are preparing like this? Because settlement occurs in downward direction. Fine. Just to show that downward settlement, I am drawing the system like this. Okay. So don't get confused from that point of view. Here, time versus settlement curve for the clay soil. Okay, I can draw time versus settlement curve is something like this. This time versus settlement curve I have drawn under the additional pressure of I can write delta sigma. So what is the settlement? this is the settlement S1 when we have applied delta sigma pressure. You assume there is a plot and you have prepared one floor structure. You have prepared one structure of one floor only. So what is the settlement? Settlement is S1. This much settlement has been occurred under this value. This is the additional pressure on the soil because of one floor. Clear? And one floor building you have prepared. Now you prepare one more floor. You prepare one more floor means you are giving the increment of pressure of the same amount. Say what I have written under the same increment of pressure. So suppose you have prepared one floor structure, now prepare one more floor above this, one more floor above this. Now total there will be two floors. So when I prepare one more floor, then what do you think? Again same settlement will occur? No. Now the settlement will decrease, something like this. The settlement we have is S2. Now the settlement that we have is S2. Now here what is the increment? Same increment, delta sigma, same increment in the load. Now what will happen after some time? After some time you prepare one more floor. You prepare one more floor of same load. Then what will happen? Again the settlement will decrease. So you will find again the settlement is decreasing, S3. This time also I have applied the same pressure increment. So one thing you people will observe, soil type is same. You are applying the same pressure increments in the soil, but the rate of settlement of the soil is decreasing. Rate of settlement of soil is decreasing with the time under the same increment of loadings. The major settlement occurs in the first time, then settlement will decrease. Then settlement will decrease under the same increment of loads. So here I can write, what I can write, if you want I can write this is S1 is greater than S2 is greater than S3. The least settlement will occur at the last. Under the, in the bracket I can write, under the same increment of loads or pressures, same increment of load or pressures. That means if you want I can write, that means the rate of settlement decreases with the time, under the constant, in the bracket I am writing, same increment of loading, same increment of loading. Okay. Now one thing you people can observe here, suppose one thing you people can ask me, sir, suppose till now it is clear to me, sir, if I apply some 50 kilopascal load, the load versus settlement curve is like this, so the settlement is this much, S1. Okay, but sir, this time suppose I am applying same value, this time suppose I am applying same value of 50 kilopascal again, increment in the load, then the settlement is decreasing. S2, where S2 is less than S1. Sir, this up to here it is clear to me. Up to here it is clear to me. But sir, I am asking, sir, if I apply 50 kilopascal, so I am getting this much settlement S1. And suppose if I apply next time, the increment is 200 kilopascal. Increment is large, it's not same. Then will be the settlement less? No, this time the settlement will be more. If you apply more increment in the loads, then settlement will be more. So this time your S2 will be greater than S1. Okay. So this curve I have prepared under the constant increment of the loads. If there is a progressive nature of increasing the loads, then settlement rate will increase with the time. So that is a different analysis. Right now we have to concentrate on this study that under the constant increment of loads, the rate of settlement decreases with the time. Clear? So this was the time versus settlement curve that we have discussed in this lecture. Two types of settlement curve we have discussed. First, we have discussed for clay and sand under the same value of applied pressures. Then we have discussed about the only clay soil under the incremented values of the same amount of pressures, and we have studied both the cases. We have discussed something about the sand drains also. Clear? So this was the time versus settlement curve that we have discussed in this lecture. Thank you.